So brand new unit, coordinate geometry. It's going to be totally different than what we were just doing. Parallel lines and transversals and angles, we're getting completely away from that. Okay. All right. Evaluate each expression for A equals 6 and B equals -8. Okay. So we're going to plug those in. Number 1, so that would be the square root of 6 squared plus the square root of -8 squared, like that. And then B is going to be, or sorry, number 2 is going to be the square root of 6 squared plus the square, or sorry, plus -8 squared. Do you think you're going to get the same answer both times? Do you think that number 1 is the same as number 2? What does order of operations tell you? No. No way. Johan, what'd you get for number 1? Very good. The answer to number 1 is 14. Do you notice that the square root and the squared cancel? And the square root of 6 squared is just 6? And on the other one, when you square the -8, a negative times a negative is a positive. So the negative is going to cancel, and the square root and the squared are going to cancel. So on number 1, it is just 14. They cancel. Okay? Rishi's saying it's okay. You're not the only one. All right, number 2. Graham, what'd you get for number 2? Very good, because 6 squared is 36 and 8 squared is 64, so that's like saying the square root of 100, which is 10. The lesson that we wanted you to learn from this warm-up, is that on these you can cancel the squared and the square root. You can. But on this you cannot cancel the squared and the square root, because you have that addition underneath the radical. So you can't just cancel the squared and the square root, even though they are inverse operations. So it's really important that those are 2 totally different problems and that you get different answers, okay? So you can't just square root each thing under a square root separately. You have to add them together first. This goes first, and then you can square root, all right? So today's notes is Pythagorean theorem and distance formula, but remember I said we're also doing midpoint formula. So we have a lot to cover today. Pythagorean theorem should be a review for you. You have seen it before. It's being really dark for some reason. Okay. Good old Pythagoras. He was born in Greece in the 500s BC, so quite a long time ago, thousands of years. He's known as the father of numbers, and they attribute Pythagorean theorem to him, but then they also found that Egyptians were using it as early as like 2,000 years before Pythagorean. So he might probably not be the person who founded it the first time, but he gets the credit. We named it after him. So anyways, good to know. History is good to know. So what does Pythagorean theorem say? What does Pythagorean theorem say? It says if we take A, well, first of all, you have to have a right triangle, right? So if it's not a right triangle, then don't you dare use Pythagorean theorem. It works only on right triangles. And it says, very good, it says that if you take A and you square it, and you take B and you square it, sorry, didn't mean that, that it should equal, I'm running out of room, should equal C squared. So it says A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. So the sides, the legs are the 2 sides that aren't the hypotenuse, right? The hypotenuse is always across from the 90-degree angle. So if you're having trouble locating the hypotenuse, just draw an arrow away from the 90-degree angle. We are not doing trig yet. And trig is actually not hard, Lars. It's not hard at all. You may be right, Pythagoras, but everyone's going to laugh if you call it a hypotenuse. I guess they think it's a weird name. but that's what it is. It is a hypotenuse. And if you take 3 squared, if you square 3, you get 9. If you square 4, you get 16. And when you add them together, you get 25, which happens to be 5 squared. So that's how Pythagorean theorem works. The first thing I would do every time while you're getting used to this and you're remembering how to do this is the first time I would draw an arrow away from the box and I would circle the hypotenuse. Every time I would circle the hypotenuse because the legs are interchangeable, but the hypotenuse is not interchangeable. Yes, you've learned it. All right, so equation, a squared plus b squared equals c squared. It doesn't matter what a is and it doesn't matter what b is. Sorry, I put x. Well, that'll work. Okay. So a and b are interchangeable. Just make sure that you put c in the right spot. All right, so we've got 9 plus 49 equals x squared, right? 58 equals x squared. And then we didn't want to find x squared, we wanted to find x. So what's the opposite of squaring something? Square rooting. Chloe, what did you get for x? So we're rounding to the nearest hundredth. The number 100 has 2 zeros in it. So that means I want 2 decimal places. So you get 7.61577. And you look at the second one and you consult your neighbor. Hey neighbor, am I supposed to say the same or bump up? And your neighbor says, yeah, bump up. Because 5 and above bumps and 4 and below stays the same. So it would be 7.62. Moving on, let's try this one. Draw an arrow away from the box and circle it. That is your hypotenuse. So this one's going to be a little bit different. We're looking for a leg. We're not looking for a hypotenuse. A squared plus b squared equals c squared. It doesn't matter which one you put first. You can go ahead and square those things. X squared plus 25 equals 361. Subtract 25 from both sides. X squared is equal to 336. And then we take the square root of 336. It's asking to nearest hundredth again. So you should get, what'd y'all get? Anybody? 18.33. Very good. Now guys, if you can look at this triangle and you can go straight to your calculator, if you can see, oh, that's just 19 squared minus 5 squared, and you take the square root. If you can do that, then go for it. That is fine and dandy. You don't have to show all the work that I showed. Okay? Good job, Karthik. Okay, to get to school each morning, Cammie drives 5 miles north and 8 miles west, a total of 13 miles. How much shorter would she travel if she had a helicopter and could travel in a straight line to school? So, did you hear the helicopter? It was really light. Okay, so you draw a picture. Here's her house. Put a dot and that's her house. So she usually drives 5 miles north and then 8 miles west to get to school. So that's how far she usually drives. She usually drives 13 miles. But she was running late to school and she's really rich, and so that day she took a helicopter. You don't have to drive on the roads when you take a helicopter. You can just fly in a straight line. So the straight line distance is what you need to find, and then you can just subtract them to find out how much she saves. Okay? So we're going to do square root of 8 squared plus 5 squared. Just going straight to my calculator. And I'm getting 9.4. So the long way is 13 miles. The short way is 9.4 miles. We want to know how much shorter. So we subtract them. And so what do you get? 3.6? Yeah. She's going to save 3.6 miles if she flies in a helicopter. Has anyone ever ran 3.6 miles? Any long distance runners out there? That's not really long distance, but you ran 4. Good job. All right, we're going to move on. We're going to go to the distance formula. Now, we already talked last unit about how to find the distance on a number line. So we're good to go with distance on a number line. How do you find the distance from A to B on a number line? How did we do that? Do you remember? Sometimes I run a couple of feet to the couch. Oh my gosh. How do you find the distance on a number line? I'm looking for one word. Subtract. Very good. The absolute value of the difference. So you would do A minus B and you would take the absolute value. Very good. So today we're going to learn how to find the distance on the coordinate plane when our number line is not horizontal. It's diagonal now and it's a little bit different. Okay? So let's make sure we remember. How do you find the distance? Absolute value. It doesn't matter which one you put first. You could put 5 minus negative 3 or negative 3 minus 5. It doesn't matter. And so it's the absolute value of negative 8, which is 8. So the distance from 3 to 5 is 8. What I'm getting at here is we're subtracting. That's how we're finding the distance. We're going to find out that the distance formula is really just Pythagorean theorem in disguise. Did you know that? The distance formula is just Pythagorean theorem in disguise. So what we're going to do is to find the distance from A to B. Here's what you can't do. You can't count with your finger. You cannot count the squares diagonally. It is off limits. It's not allowed. But what we are allowed to do is we are allowed to count horizontally and we are allowed to count vertically. That's totally allowed. Okay? So, no, not a ruler. So, we're going to use these squares and we could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. We totally could just count them. But I want to know where that 9 came from. Now, if I'm finding this length right here, is that my x-axis or my y-axis? X-axis, very good. So really, I'm finding the change in x. I'm finding delta x, right? Here are my x values. This is negative 3, and this is 6. How do you find the distance from negative 3 to 6? You subtract them. Yeah. 6 minus negative 3. What do you get? You get 9. Okay, so this is 9. We agree that this is 9. Cool. Now let's do delta y. And we can all see that it's 2, but let's make sure we know where that's coming from. The y's are 3 and 5. This is 3, and this is 5. How do you find the distance? You subtract them. 5 minus 3. And that's 2. Now, how would we find that side if we did Pythagorean theorem? Well, we would say a squared plus b squared equals c squared, right? And what's always the last step of Pythagorean theorem? Always. What is always the last step? Square root. So then you would square root. And there it is. That is the distance formula for you right there. That is the distance formula. Woo! And we just derived it ourselves with Pythagorean theorem in the coordinate plane. So this is really 9 squared plus 2 squared, and it's the square root. See, that's Pythagorean theorem right there. And that is the distance formula. So they're really just the same thing, okay? So we kind of already talked about this. If we were to solve for c, it would look like this. c equals the square root of a squared plus b squared. So that's what the distance formula is. Go ahead and write this down somewhere. Go ahead and write this down somewhere. This is the distance formula. Yeah, you don't need both, but delta x means subtract your x's. Delta y means subtract your y's. Do you agree that this one would be easier to memorize than the other one with all those subscripts? So if you know that delta means subtract, then you might be better off memorizing the second one rather than the first one. So that's why I put both of them up there. I wanted you to have options. Options are always good, right? We like options. Okay, I'm going to move on. I will send y'all a formula chart that you can have, and so if you didn't get to copy that down, it'll be on your formula chart, okay? All right, let's practice. Find the distance of the points to the nearest tenth, between the points, sorry. Now, oh good, you got one, good. Now here, I'm going to teach it a certain way. And I'm going to teach this way so that every single student can get it. If you feel like this way is babying you and you don't want to do it this way, that is perfectly fine. But I'm going to teach it in a way so that all students are successful. The first thing I want you to do is circle your X's and underline your Y's. Circle your X's and underline your Y's. Circle your X's and underline your Y's. The next thing that you do is you draw what I call a skeleton. And it's really appropriate because we're in October, right? We're in October now, so we're going to draw a skeleton because it's close to Halloween. I always draw a skeleton of the distance formula first with no numbers plugged in. And the reason I do this is so that I won't mix up my negatives and my pluses and my minus a negative. I promise it helps. You can still call it a skeleton after October, yes. So now what you do is you take your circled numbers and you put them in parentheses. And you take your underlined numbers and you put them in parentheses, okay? I'm going to start with this one first, so I'm going to put the 2 first. I'm just going to take my circled numbers, I'm going to put them in. 2, negative 3. Now I'm going to take my underlined numbers and put them in. 8, 1. So these are my X's and these are my Y's. So you keep the circles together and you keep the underlines together. It's kind of like if you have a dog who really doesn't like a cat, you're not going to put them in the same pen together, right? You're going to put your dogs with your dogs and your cats with your cats. Maybe, I don't know. But keep your X's together and keep your Y's together so they don't fight, okay? Now, the hard part is over, and now we can just solve it. 2 minus negative 3, that's 2 plus 3, that's 5. 8 minus 1, that's 7. Look, now it looks just like Pythagorean theorem. Square root of 5 squared plus 7 squared. I go straight to my calculator. Square root of 5 squared plus 7 squared. And we should all get 8.6. If you did not get 8.6, let me know. You need a calculator for sure. Okay, let's move on because I told you we have to go fast today. Find the distance to the nearest hundredth. While you're getting used to this, please circle your X's and underline your Y's. Do not begin a problem until you've circled your X's and underlined your Y's. You're going to get tired of me hearing that. Now you're going to do your skeleton. Your empty distance formula with nothing plugged in. Minus, minus, plus. Do you remember why there's minuses in the parentheses? That's because that's for the delta. You're subtracting. You're finding the difference in the X's. You're finding the difference in the Y's. Oh, sorry. Move my mouse. You're right. Okay. It won't move. Okay, now we're going to put the X's together. 9, 5. We're going to put the Y's together. -1, -2. The circled ones go there. Make sure you put if you put the 9 first, you better put the -1 first. Make sure you go in the same order each time. Good. To find the midpoint on a number line, we are going to add our X's. We're going to add our X's and divide by 2. And then we're going to add our Y's and divide by 2. And that'll get us the middle of the X's, and that'll get us the middle of the Y's. So you're going to find the average of the X's, you're going to find the average of the Y. It's very easy. You're totally right. So did we do it right? Will that get us in the right spot? 8 plus 3, 11. 11 divided by 2 is 5.5. 3 plus 5, 8. 8 divided by 2 is 4. Let's see. Let's go over 1, 2, 3, 4, 5.5. And then go up 4. 1, 2, 3, 4. Wow! That landed right where I thought it should land. So, you can write this down or you can just find it on your formula chart. That is the midpoint formula. It is the average of the x's and it's the average of a y, of the y's. You would never add an x to a y. Never put a cat and a dog in the same crate. So keep your x's together and keep your y's together. They're separate, okay? I know it's easy peasy, I know. Okay, so go ahead and try this one. Find the coordinates of the midpoint of segment TR. It's a dog-eat-cat world out there. Okay, go. All right, here we go. So to find the midpoint, we would add our x's and divide by 2. And we would add our y's and divide by 2. Here's the only way you could mess this up. Are you listening? The only way you could mess this up is if you go to your calculator and you do -1 plus 7 divided by 2. Why would that give you the wrong answer? Yeah, it would only divide the 7 by 2. It wouldn't divide the -1 by 2. So you need to put parentheses around it, or you could just do it in your head, right? -1 plus 7, so that's 6 divided by 2. This one is 3 minus 1, that's 2 divided by 2. And then if you really needed to, you could go to your calculator. But make sure you put parentheses around the numerator. Put parentheses around the numerator. The answer to this problem, the midpoint, I'll call it M, the midpoint is 3, 1. Moving on? Moving on. All right. Raise your hand. Well, I can't see all of you at once. If you've ever played leapfrog. Y'all ever played leapfrog? There you go. You can raise your hand up there. Okay. So leapfrog is when you jump over someone who's crouched down, and then you crouch down, and they jump over you, and then you jump over the other one like that. Okay. So to find the end point of a segment, we are going to play leapfrog. This is not to find the midpoint. Stop raising your hands. This is not to find the midpoint. This is to find an end point. So in your notes, make sure you write end point. Now, we're still going to do the same thing that we've been doing. We're going to circle our x's and underline our y's. And now what we're going to do is we're going to leap. If we leap from 2 to 7, how far do we travel? 5. Yeah, 7 minus 2. We travel 5. So we want to leap the same amount again. 7 minus 2 is 5. So we're going to leap 5 again. If you're at 7 and you go forward 5, where are you going to land? 12. Make sure you put it in the X spot. We're doing X all by itself. Now we're going to do Y all by itself. If you leap from 9 to 4, how far do you leap? Good. You're getting smaller, so you're leaping backwards. Be careful, it's -5. And so now we're going to leap -5 again. If you're at 4 and you go backwards 5, good. 4 minus 5 is -1. So the end point, the answer, is 12, -1. That's the answer. All right, so try this one. I give you the midpoint. I give you an end point. I want you to find the other end point. The only thing that's really important in a problem like this is make sure you put the midpoint in the middle when you're setting this up. You make sure you put the midpoint in the middle. So I'm going to put my end point, then I'm going to put my midpoint, and then I'm going to put my other end point. Make sure you put the midpoint in the middle. Circle, circle, underline, underline. How far do you leap from -1 to 3? Plus 4. So you're going to leap plus 4 again. 3 plus 4, and you should get 7. Okay? How far do I leap from 3 to 1? -2. So we're going to leap -2 again. 1 minus 2, -1. So our answer is 7, -1. I'm going to keep teaching. I was asked, how do you know the end point? Look, it was given to you. This was given, and this was given. You have to be given 2 of the points or else you can't solve it, okay? All right, next one. B is the midpoint of AC. Find the coordinates of C. So be careful. B is the midpoint, so make sure you're putting that one in the middle. Make sure you're putting it in the middle. So I'm going to put 0, 15, then negative 3, 7, then empty, empty. Circle your X's and underline your Y's. From 0 to negative 3, you're traveling negative 3. So if you go negative 3 again, you're going to be at negative 6. From 15 to 7, you're traveling negative 8. We always end up at negative 1 for some reason. And then 7 minus 8 is negative 1. So your answer is negative 6, negative 1. Very good, very good. Okay. A coordinate grid is placed over a map of Cyprus. You want to meet a friend that goes to Cy-Fair for dinner. You want to find a restaurant in the middle of Cy Falls and Cy-Fair. What coordinates should the restaurant be close to? Bye. Okay, so on this one, first of all, you kind of want to note what coordinates you're at. This star is over 2, down 1. So Cy Falls is at 2, negative 1. Cy-Fair, it's right off of 290. It's at negative 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So it's at negative 5, negative 6. Sorry, positive 6. If you want to find the midpoint to find out where the restaurant would be located, right in between those two schools, you're obviously finding the midpoint. You're going to use the midpoint formula. So you add your x's and divide by 2. Circle, circle, underline, underline. So add your x's, that's a plus, but it doesn't matter. And divide by 2. And add your y's, oops, sorry, negative 1, 6. Add your y's and divide by 2. Let's see. Negative 5 plus 2 is negative 3. Negative 3 divided by 2, so it's negative 1.5. And then negative 1 plus 6, so that would be 5. 5 divided by 2, that would be 2.5. So your meeting place would be negative 1.5 and then up 1, 2, and a half. So you would want to meet right off of 290, right before Telgi is where you would meet. Right before Telgi. Okay. So that's kind of just trying to show you how you could apply this to the real world. Then it says, how far will you have to drive? So you're going to drive from Cy Falls to the restaurant. So that's not midpoint formula, that is distance formula. Yeah, that's distance formula. So now we want to find the distance between, this was Cy Falls, and this is the restaurant. So that's when we would do our nice big skeleton, minus, minus, plus, squared, squared. Circle your x's and underline your y's. We don't need this anymore because that was Cy-Fair. We're done with that one. So now I put my circles together. Circled, circled. Now I put my underlines together. Underlined, underlined. And now you can just go straight to your calculator, or you can clean it up and then go to your calculator. 2 plus 1.5 squared, and then negative 1 minus 2.5 squared. What does everyone get? Bye. I'm getting 5 miles, 4.9 to be exact. I'm getting 5 miles. Another way we could have done this, if we didn't want to have to deal with decimals, is we could have found the whole distance, right? And then just divided by 2. So that's another way you can find the distance from the end point to the middle, or you can go from end to end and simply divide it by 2. I'm going to keep going. If line DE is the perpendicular bisector of AB and intersects AB at point C, find the coordinates of C. So I wanted you to see this problem because although it sounds really tough, it is not a tough problem. You just have to figure out what they're actually asking you for. It's not a tough problem. You just have to figure out what they're actually asking you for. If it's the perpendicular bisector, then that means it goes through the midpoint and it hits it at a 90-degree angle, right? So if I just eyeballed it, it would look something like that, even though that's not exact. So what I'm really trying to find, all I'm trying to find is really just a midpoint. So it's a problem that sounds complicated, but that really isn't that complicated. Quan, you'll have to figure it out with numbers, not with a compass. Yeah? Okay. So really, I just need the coordinates, and I just need to find the midpoint. So A is at -2, 2. And B is at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 7, -4. So I'm going to use my midpoint formula. I'm going to add my x's and divide by 2. And then I'm going to add my y's and divide by 2. That's all there is to that one. You can go ahead and solve it. I'm going to keep going. Segment HI has an end point at -2, 5 and a midpoint at 3, 8. What is the length of HI to the nearest hundredth? Hopefully you're thinking to yourself, well, if I have an end point and a midpoint and I find the distance, then that distance is going to be half of my whole segment. Because from end point to midpoint is halfway across, right? So if I can find the distance between those two and then just double it, then that'll give me the length of the whole segment. So I would just find the distance between those two and I would just double it. So here's my distance formula. I always draw the skeleton first. Squared, squared, minus, minus, plus. Put my circled numbers together and my underlined numbers together, but make sure you go in the right order. If I go here to here, I better go here to here. And then I'm just going to double that. So I will also let you just work on that one, but you are going to double the distance from the middle to the end. Times 2. Okay, and we're going to deal with this one on Monday, because this is going to be tomorrow's warm-up, but we're going to deal with this one on Monday, and we'll take plenty of time to explain it. Woo!